Hello everyone, welcome. I think we have a new circuits here. We have 3 circuits here. And the first circuit is this LED, diode, resistor, and connected to a battery source or a dry cells. This is 12 volt supply. And the battery or the dry cells is connected in series. We have 8 1.5 volts dry cells here or battery connected in series. That's why it's 12 volt supply. 1.5 times 8 pieces, 12 volts. So this is our first circuit. And then we have this a transformer with the LED and a resistor behind and a diode. Here I'm using diode 1N4007. In here I'm using diode 1N4007. And it is connected into the 220 volt source. In here we have a lamp circuit that is 220 volts connected to 220 volts. That is a Philips LED Classic design. That is the new LED bulb design manufactured by Philips, and it's nice, connected to 220 volts. Let us kill the light because it's very bright. The objective of this circuit is to know the current flows in the transformer by connecting a load LED and a diode and using 220 volt source and the diode combination and the transformer. And let us see the circuit diagram. Where is the circuit diagram? Let us take a closer look at the circuit. This is the 12 volts battery supply connected to this circuit, and we have here a transformer, 220 volts step down to 12 volts, and in here there's a LED resistor diode connected to the 12 volt supply, and this bulb by the Philips, and it is not a tungsten filament, and it is an LED bulb manufactured by Philips, and it's nice. It's not a tungsten filament, it's an LED. It's cold, it's not warm, just a little warm. New technology by Philips. Let us kill the light, it's very bright, and let us see the circuit of this one. This is lamp circuit, 220 volts, and we have the circuit diagram, and this is the symbol for alternating current, negative, positive, circle, and there's some sort of wave here. They call it sine wave. And this is 220 volt source, AC alternating current, and 60 Hertz. This is frequency. This is the voltage supply, switch, and also the lamp. So since this is our previous circuit, and if you're interested, you can watch the video, but we can have a quick review of this circuit. Using 220 volts alternating current means AC current flows here to the lamp, and then reverse, clockwise, counterclockwise, because this is alternating current. And this is, they call it a sine wave or alternating current. Sine wave by our math teacher, our high school teacher, or maybe college professor, or maybe genius masters in YouTube masters. In here we discuss here what is this 60 Hertz. That is the frequency provided by the electrical company at the same time 220 volts 60 hertz voltage supply provided by the electrical company, and that is hertz is a unit of frequency, and we know that, remember that 1 hertz is 1 cycle per second, 60 hertz 60 cycle per second. So there is 60 cycles, 60 times or 60 pieces of this flowing into the circuit in just 1 second, flowing back and forth 60 times, 60 cycles, 60 pieces of this, and that is the frequency. So it is not only 220 volt source alternating current, but also a frequency is being provided or is provided by our electrical company. So it flows back and forth 60 times in just 1 second. So if you touch the wire, you will be electrocuted or you will get burned, because 60 pieces of this sine wave is flowing into your body in just 1 second. Imagine that. That's very strong current or voltage. So we now know that the frequency is cycle per second, that it's measured. The unit of frequency is hertz. This is a scientist. Hertz. And hertz is cycle per second, 60 hertz or 60 cycle per second. That is the equivalent circuit of this bulb. You're just putting a resistor here. So that is our lamp circuit. And we have this circuit. That is a diode circuit. We have 12 volts direct current. This battery is providing us a direct current, but the lamp is using 220 volts alternating current. So in here we have switch, the diode. I'm using 1N4001, and we have resistor to protect the LED, and the LED is the red 10mm. And we have the circuit diagram. And since this is our previous circuit, we discussed something here, the symbol, the parts, the layouts, but we can make a quick review of the current flows here. Current flows here in just one direction, since this is direct current provided by the dry cells or the battery. Current flows only in one direction, unlike here 220 volts alternating flows back and forth. So that is the alternating and direct current. So what we have here now is our new circuit, and we have here Transformer-1N4007 Circuit. That is the name of the circuit, and this is the circuit diagram. As usual, we have the lamp here connected to 220 volts, and we already know that is the 220 volts. Also, this coil design or drawings, it is a transformer. This is the transformer. And also this diode here, a resistor and LED. As you have seen here, I'm using this circuit. This is our previous circuit, a diode circuit, to connect into the transformer. And then I'm using lamp here, that is our previous circuit, just to illustrate or to discuss that we are connected to 220 volt source. It has its own switch. If you push the switch, that is the LED classic design bulb by Philips. Very nice. Some sort of Thomas Edison first electric bulb. Just like that. See that? That's made up of LED, not a tungsten filament. Okay, let's kill the light. It's so bright. So let us see the circuit now. What we have here is we're going to see where the current flows here in the transformer. So when they're using 220 volts AC alternating current, and we know that the symbol alternating is a sine wave, and this is the sine wave by our math teacher and the YouTube masters. And here flows here when you close the switch to the transformer. The current flows into the coil of the transformer, inducing a voltage, induced voltage here, producing a current to the diode 1N4007, to the resistor, into the LED, and then to the ground. But that is only one cycle, or I mean half cycle, because we are using this sine wave alternating current, so it reverses its direction into counterclockwise, negative direction. First half wave, second half wave. This is the full wave. First half wave, second half wave. First half wave positive, second half wave negative. So we have a sine wave here flowing into the circuit back and forth because we're using 220 volts. What happened to the diode? What do you think? So the purpose of this diode, since this is combinational circuit, I just put it as a load to the transformer so that we get new circuit here, is act as a rectifier. Well, according to YouTube masters, rectification is converting alternating current to the recurrent. So it means that this diode is converting the alternating current to the recurrent. So the current flows now here is the recurrent. If that is the recurrent, it should be look like this, a flat line, the recurrent. Just like this one, a battery. This is the recurrent voltage supply. So in here, since we don't have oscilloscope, we can draw using a ball pen what is the waveform of the waveform here. Since this is sine wave, when it enters into the diode, it produces this wave. Only the half cycle has been passed into the diode, because in a positive cycle, this half cycle, the diode conducts or turns on, while during the reversal or into the negative back and forth cycle, the diode is turned off, because the diode, as we all know, has a forward biasing, forward voltage, forward current, and all the current flows only in this direction, positive to negative, because this is also served as a switch. So when during the negative cycle, or this cycle, the negative half cycle, the diode is turned off or off. That's why there's no wave here. The negative wave has been removed, or delete, or erase, or does not exist, or cut off, or cutting the wave here. Only the positive during the first half wave, positive, the diode is having this waveform. Conducts during the negative, reversing the current. Since this is alternating current, it has no wave here. That's why the waveform is this. Some looks like parabola, or a mound, or a mountain, but that is the waveform of the diode here. After passing the diode, that is the waveform, or the current. We cannot see the current, but we can draw the signal or the waveform of the current here, just like this, after the alternating current is passing through the diode. So this is one cycle. It means 1 Hertz. We are discussing this in just one cycle. I mean, we're using just one cycle to discuss. How about 2 cycles per second? 2 hertz. So it means in one cycle the waveform look like this. So the second cycle, it looks like this. Another negative cycle is being removed or does not exist. So it looks like two mountains separated by space, because this is a first cycle, second cycle. Only the positive cycle has been passed, or during the diode is forward biased, the diode is turning on, or the diode turns on during that cycle, the positive half cycle. And whenever there is a reversing current here, the diode is turning off. So it is served as a switch. So this is the waveform now of the continuous supply of waveform or current in a circuit. So we now see the waveform, not just like current flows here. We can now draw the waveform here. Two mountains. So the third cycle should be like this. There's another one, and so on. So they call it a sine wave by our math teacher and the YouTube masters. And we know that the recurrent is this straight line. And what do you think now is the current here? What do you call the current here? It should be 12 volts alternating current or 12 volts direct current. Others said it is 12 volts alternating current, 12 volts direct current. But for me, since this is some sort of pulsating waveform, I called it pulsating direct current. So this is not just a regular name direct current here. This is pulsating direct current. This is the direct current, straight line. But this is pulsating direct current produced by this diode 1N4007. Only during the first half cycle, second half. The first half cycle is positive. Second half cycle, negative. Full cycle. Only the diode conducts in this region during the first half cycle. So this second cycle, always the positive half cycle. So you see this pulsating direct current. And we have a layout here. Transformer, LED, resistor, diode, and that is the actual circuit. But can you see the pulsating direct current here? I think we can see it in the LED, since we don't have oscilloscope, but we can still see that this is not a direct current. Unlike here, this is a direct current supplied by the battery. Did you see the difference? It is some sort of glowing here. It's glowing. It's very hot. It's glowing. Okay, let us check if it is pulsating. See that? It's pulsating, right? The LED here is pulsating direct current. The LED to the right is steady. That's the original direct current. This one is pulsating. Did you see the light? See? It's pulsating. It's pulsating 60 cycles per second. That is 220 volt source. And in here, it is 12 volts provided by the battery and steady. See? It's not pulsating here. It's pulsating. So that is the pulsating direct current produced by the diode. And this is kill the light. It's so bright. See? So in here, it is just glowing, pulsating. See the difference of the two LED? It's pulsating, some sort of glowing. Here, just steady. That is the current flows here and the current flows there. And we now